Now you are in part 8. It's ratios of compound angles. I will show you in this video how to find the formulas. You need to memorize some of the formulas, how you find the remaining formulas. First, we're gonna see sine A plus B, sine A minus B. Sine A plus B, you need to memorize it. Sine A cosine B plus cosine A sine B. So how are we gonna find sine A minus B from it? It, as we are saying, sine A plus minus B. So instead of B, I'll put minus B. Cosine minus B, cosine minus alpha, it's the same as cosine alpha. So the first part is gonna stay the same. Sine minus alpha, it's minus sine alpha. So now the plus is gonna be minus. So sine A minus B will be sine A cosine B minus cosine A sine B. So here is minus, here is minus, here is plus, here is plus. For cosine A plus B, it's cosine cosine minus sine sine. So it's the signs are opposite. Now how are we gonna find cosine A minus B? I will replace B by minus B. Cosine minus b, it's the same as cosine b, so nothing gonna change in the first part. Sine minus b, it's minus sine b, so gonna be this one gonna be plus. So that's why now the cosine, they are opposite. Here is minus, here is plus, here is plus, here is minus. Now let's move to tangent. Tangent A plus B, the formula is tangent A plus tangent B over 1 minus tangent A tangent B. And again, if I want to find tangent A minus B, all what we need to find, replace B by minus B. So here gonna be minus because tangent minus alpha is minus tangent alpha, and here gonna become plus because it's minus times minus plus. Now, after those formulas, we can deduce the double angle identities. It means sine to A, cosine to A, and tangent to A. To find sine to A, it means I'm saying sine A plus A. So let's go to the formula sine A plus B. It's sine A cosine B. And sine A cosine A plus cosine A sine A. So it means it's equal to sine A cosine A. If I go to tangent to A, it means I have tangent A plus A. The formula, tangent A plus tangent A over 1 minus tangent A tangent A. So it's going to be 2 tangent A over 1 minus tangent squared A. Now if I go to cosine to A, also, it's cosine A plus cosine A. And then we know that the formula is cosine cosine minus sine sine. So it's going to be cosine A minus sine A sine A. So it's cosine squared minus sine squared. But for cosine to A, I have three formulas. I have one in terms of cosine and sine squared, one is just in terms of sine squared, and one just in terms of cosine squared. How we can deduce that? No need to memorize it. If I replace now cosine squared by 1 minus sine squared, what I will have here? 1 minus sine squared minus sine squared, so it's 1 minus 2 sine squared. And if I replace sine squared by 1 minus cosine squared here, I will have cosine squared minus 1 minus cosine squared, so plus cosine squared. So cosine squared plus cosine squared is 2 cosine squared minus 1. And also, guys, you can deduce sine squared and cosine squared from those two. So you can solve for sine squared. It's going to be cosine to A minus 1 over 2. And cosine squared is only 1 plus cosine to A over 2. It's just very simple. Just you need to memorize it. Now let's move to the application. So we're gonna understand why do we need those formulas. Those formulas, sine A plus B, cosine A plus B, and minus, those will help me to find the exact value of sine and cosine of non-unknown angles. We know that in the unit circle, we have unknown angle 30, 60, 90, 0, pi. We have all those angles that are particular. But for example, 75, 105, those are not angles that I memorize. I can memorize their values. So how do you gonna find sine 75? You're gonna think about decomposing 75 to the sum or the difference of two known angles that I know. 75 is 30 plus 45 because I know sine 30 and cosine 30 and the same for 45. And now I will use the formula sine A plus B. It's sine A cosine B. So it means it's sine 30 cosine 45 plus cosine 30 sine 45. We just replace half times radical 2 over 2 plus radical 3 over 2 times radical 2 over 2, and then the answer will be radical 2 over 4 plus radical 6 over 4. Exactly the same for 105. 105 is not one of the angles that we know from the unit circle. We decompose it to the sum of two angles that we know, that it's 60 plus 45. Then I use the formula tangent A plus tangent B over 1 minus tangent A tangent B, and I will get the answer here. And then we need to rationalize it by multiplying by the conjugate of 1 minus radical 3. It's 1 plus radical 3. And after doing the develop and the calculation, I can find the answer. It's minus 2 minus radical 3. Guys, I'm going fast because I want to finish it all in one video. Sine 33, cosine 3 minus cosine 33, sine 3. Here also, 33 and 3 are not one of the angles that we know. But this one will remind you of sine A cosine B minus cosine A sine B. So this is sine A minus B. So this is sine 33 minus 3. So this is sine 30 that I know it from the unit circle, so it's half. Here the same. It's cosine, cosine plus sine, sine. It's cosine A minus B. So it's cosine 75 minus 15. Be careful, guys. Those should be the same angle. 75, 75, 15, 15. So it's cosine 60, and it's also half. You move to exercise 5. Given A is an obtuse angle and given sine A, B is an acute angle and given sine, we need to calculate cosine A minus B and tangent A plus B. And those we need all the cosine and the sine of the angles. Now, the information A obtuse will show me that A is in quadrant 2. What does it mean? It's cosine negative. So it means that now when I want to use sine A to find cosine A, which value are going to take? The negative one. So to find cosine A, I will use sine squared plus cosine squared A is equal to 1. And then I will find cosine squared, and then I'll take the just negative because I'm working in quadrant 2 because it's an acute angle. For B, it's an obtuse. For B, it's an acute angle. It means I'm in quadrant 1. Quadrant 1 means sine and cosine are positive. So from sine, I will get cosine, but I'm going to take the positive value. Now I have sine and cosine. To find cosine A minus B, I just use the formula. It's cosine A cosine B plus sine A sine B. You replace, you plug in, you calculate. To find tangent A plus B, it's tangent A plus tangent B over 1 minus tangent A tangent B. You're going to ask how you're going to find tangent. Sine over cosine gives me the values, and just you replace and you calculate. It's very simple. It's just about calculation. Prove the following identities. I will not do it all. I just picked the one that's a little bit complicated. Cotangent A plus B, I want to prove that it's equal to cotangent A, cotangent B minus 1 over this one. So first, cotangent A plus B, it's cosine over sine. Excellent. And then we know the formula we develop. It's cosine A cosine B minus sine A sine B over sine A cosine B plus cosine A sine B. Now let's compare where I want to reach. I want to reach to cotangent, so sure I need to have cosine over sine. And here I need minus 1, so sure this one should be gonna come minus 1. So what's gonna make this one minus 1? By dividing up and down by sine A sine B. So if I would divide up and down by sine A sine B, here it's gonna be cosine A over sine A, it's cotangent A. Cosine B over sine B, cotangent B. Sine A sine B over sine A sine B, it's 1. Sine A cosine B over sine A sine B is gonna be cosine B over sine B, so it's cotangent. And this one over this one, we simplify the sign, it's cosine over sine, so it's cotangent, and we got the answer. You will tell me how you're going to think about dividing. By practicing, you will get to this point. Part B, I need to prove this equality. Sine A plus B over cosine A cosine B is equal to tangent A plus tangent B. So first here, I will develop the numerator. It gives me sine A cosine B plus cosine A sine B. And then I split them because it's the same denominator. So I can split them. And now you can simplify here. Cosine and cosine simplify. Sine A over cosine A gives me tangent. And cosine A over cosine simplify. Sine B over cosine B gives me tangent B. And then I got the answer. We move to part E. Secant squared plus cosecant squared, I want to prove it to this one. So I start first by secant to change it to 1 over cosine squared. Cosecant 1 over sine squared. Now the best way when I want to add two fractions, I need to have the same denominator. So it's the multiply the first one by sine squared, the second one by cosine squared. So it's going to be sine squared plus cosine squared over cosine squared times sine squared. Here it's 1. I can separate the fractions. 1 over cosine squared times 1 over sine squared. What is 1 over cosine squared? Secant squared, and this is cosecant squared. Proved. F. F, I need to reach to cosecant. First, the cosecant theta I replace by 1 over sine, and this one cosine over sine. Over 1 minus cosine theta. So now, here, I have the same denominator already, so the numerator will be 1 minus cosine over sine theta, divided by 1 minus cosine theta, divided by a fraction times the inverse. It means it's going to be times 1 over 1 minus cosine theta. You simplify, the answer is 1 over sine, so it's cosecant theta. Guys, when you are practicing, you will find that it's not hard, it's easy. Now here again, I want to prove 1 plus cosine 4x minus sine 4x equal to cosine squared. If you look at this part here, this one will remind me of a squared minus b squared. So I can factorize it by, all the time you need to go this way. This one I cannot touch it. I just need to use the first part. 1, it's still here. This is a squared minus b squared. So it's a minus b, a plus b. Because the squared, this is 4, so it means a is squared. What is cosine squared minus sine squared? I'll leave it as sorry. What is cosine squared plus sine? It's 1, and then I will have 1 plus cosine squared minus sine squared. This is cosine. I need to keep it because I want the answer to be cosine squared. What is 1 minus sine squared? It's cosine squared. What is cosine squared plus cosine squared? It's 1. It's 2 cosine squared. I have secant theta plus tangent theta. I need to prove it equal to cosine over 1 minus sine. First of all, secant, it's 1 over cosine, plus sine over cosine. So it's 1 plus sine over cosine theta. Now, if I compare to the answer that I need to reach, I need 1 minus sine theta somewhere. So let's multiply up and down by 1 minus sine theta. The numerator is going to be an identity, a plus b, a minus b. So it's a squared minus b squared over cosine theta 1 minus sine theta. And what is 1 minus sine squared? It's cosine. Now, if you simplify, you're going to have cosine over 1 minus sine theta. Guys, you will see, you will say, how can I reach it? How can I think about that? Guys, when you are practicing, you will do it. Don't worry. J, now I have sine A tangent A over 1 minus cosine. Again, sine, I will replace sine A tangent A over 1 minus, I will multiply by the conjugate of the denominator. I multiply up and down by 1 plus cosine A. Then down is going to be 1 minus cosine squared, so it's sine squared. And the numerator will be sine A tangent A, 1 plus, 1 plus cosine A. You simplify the sine, I'll have tangent over sine times 1 plus cosine A. Then I will, here I have, instead of tangent, sine over cosine, divide by sine. It means it's sine over cosine times 1 over sine. We simplify. It's 1 over cosine times 1 plus cosine A. So it's 1 plus cosine A over cosine A. If you separate them, it's 1 over cosine plus cosine over cosine. 1 over cosine, it's secant, and plus 1. The last exercise, I hope I still have time, number 7. I need to express tangent A plus B plus in terms of tangent A, tangent B, and tangent C. I need to calculate. Now let's start the first question. Tangent A plus B plus C. So I took this one, it's one term. So tangent something plus something. It's tangent the first term plus tangent the second over 1 minus tangent the first times tangent the second. Then again here I'm using the formula again. What is tangent A plus B or B plus C? It's tangent B plus tangent C over 1 minus tangent B tangent C. And the same here. And now I can do the same denominator up and down. So I multiply up by 1 minus tangent B tangent C, and also the one here also by 1 minus tangent B tangent C, and then I can simplify the denominators. So here I'm going to have tangent A times 1 is tangent A. I still have plus tangent B plus tangent C, and tangent A times minus tangent B tangent C, it's here. In the denominator, I will do the same denominator. 1 times 1, it's 1. Now I have minus tangent B tangent C, it's here. And I have here minus tangent A tangent B and minus tangent A tangent C. It's just about developing. The second question here, I need to replace to find tangent A plus B plus C, because here they gave me the values of tangent A, tangent B, and tangent C. I need to replace it. So all what we need to do is I just replace and I calculate, and I got the answer is tangent is 1. But since A, B, C are acute, so I just have to take the positive tangent. So A plus B plus C is equal pi over 4. The last question, they said if A, B, and C are the angles of a triangle, show that the sum of their tangent is equal to the product. If it's a triangle, it means their sum is 180. It means tangent A plus B plus C is tangent 180, it's 0. Then I go to this fraction. A fraction is equal to 0 and my numerator is equal to 0. So I have this one is 0. So I have tangent A plus tangent B plus tangent C minus the product is 0. I take all the product to the other side, and I got that the sum of the tangent in a right triangle, the sum of the tangent of the angle is equal to the product of the tangent. Guys, I was going so fast because I want to finish it, but it's really easy. Just practice it again, and you will get it. It's not hard at all. See you in the next video.